Hi guys, 2.4, dividing polynomials and the remainder and factor theorems. So our chapter is called Polynomial and Rational Functions. And this is where rational functions comes into play. We're actually going to test after 2.5 and then look more at rationals, but we get rationals by dividing polynomials sometimes. So I'm going to show you long division because I know that was kind of a tough thing for us last year. And then I'm going to talk to you about the remainder and factor theorems, which are based on division. Okay, so we're going to start with objective 1, use long division to divide polynomials. And I have shown you example 3, 6x to the 4th plus 5x cubed. It skips the squared, goes to plus 3x and minus 5. And you always have to have your guard up for that, because when you go to divide, you have to make sure that you put in placeholders for any missing degrees as you step down through your polynomial. It has to go 4th power, 3rd power, 2nd power, 1st power constant. Okay, you also have to be careful of that on the outside. This went from 2nd power to 1st power. We don't need to put a plus 0 actually out there for the constant. And here is our algorithm. That just means that repeated process. Some people, some mathematicians call this the division algorithm. Divide, and I say dad divide. We think about dad maybe being the oldest one in the home. Mother multiply, sister subtract, and then brother bring down. Has to be in that order. So dad, mom, sister, brother. Okay? So the divide step, I've colored that in blue, and over here you see some blue as well. Remember, divide, we take the first term inside and divide it by the first term outside. Okay, so over here I've shown, and it's fine to have some scrap work somewhere, but 6x to the 4th divided by 3x squared is 2x squared. And so you're going to take the 2x squared and you're going to put it on top, and it has to go in the like term column. So we see right off the bat, if we didn't have that 0x squared in there, we wouldn't have a column to put this in. Okay, and I'll show you another thing that will come along here in a minute. So that's the divide step. Now we're going to go to the multiply step. And remember, this is just like you did in elementary with numbers. We multiply what we just wrote on top, the 2x squared, by the outside. But we actually multiply it by both. And I've shown that over here. We have 2x squared times 3x squared minus 2x, and we get 6x to the 4th minus 4x cubed. Okay, and we write that down, we record it underneath. Notice how our columns all have like terms in them. That's going to be important because sister subtract is next. And when we subtract, we can only add and subtract like terms. Okay, so I want you to pretend like you put a minus here and parentheses around everything. That's going to cause the 6x to the 4ths to cancel out. And 5x cubed minus negative 4x cubed gives us 9x cubed. Okay? And then we bring down the 0x squared and we start again. I'll get it later. Thank you. Okay, so we have the 2x squared still up there. Here's the 9x cubed, and here's that subtract that I asked you to envision before. And here's the bring down the 0x squared. Now, if you bring down, you probably have to start all over again, or at least we should try. So we start with divide again. This time, it's this lead term that we're down to inside. This 9x cubed, still dividing by the 3x squared, to give us 3x. And I made specific point to put positive 3x because we're going to put it up here above the other x to the first term, and we need to connect it either with addition or subtraction. 3 was positive, so it's addition. The multiply step has us take this term and multiply the 3x by both of those. That is not new. We're going to be doing the same things over and over again. If I am going too quickly, I want you to pause whenever you need, back it up to slow it down. So I took 3x that's on the top and multiplied it by the 3x squared minus 2x that's on the outside to get 9x cubed minus 6x squared, which again, we record right underneath. I don't normally have these side steps out here, but I know that some of you need to see them, so that's why I'm showing them to you. If you can do this successfully with none of these side steps, this scratch work out here, I'm okay with that. But if you need to write something down to help you, then that's fine. Okay, so we're going to subtract these. Again, remember, you put the subtraction outside the parentheses, and then we're going to bring down the 3x, and I'll show you that on the next slide. All right, so when we subtract, we actually get positive 6x squared. Again, if we hadn't put this 0x squared in there, we would not have a like term right here, and we have to have that. That can be a clue for you. If you're going through and all of a sudden you don't have like terms, if you had brought the 3x down, but then you have 6x squared underneath it, you probably missed a 0. Okay, so now we bring the 3x down, and you continue this process. Okay, the divide step, we get a 2x to put on top by taking 6x squared divided by 3x squared. That's a, no, that's not a 2x. That's just a 2. All right. And then we're going to multiply the 2 by the 3x squared minus 2x. Well, I don't know what was going on here. Let me fix that. There we go. And that is going to give us not 9, but 3 minus negative 4 is 7x. And we bring down the negative 5, okay? Notice that when we go to take 7x and divide it by 3x squared, this x degree is smaller than that one, and that tells us we've come to our remainder. So our remainder we attach as a fraction at the end. We either have to add or subtract this fraction, okay? And so we're going to add, in this case, in most cases we'll add for us right now, the 7x minus 5, which was down here as our remainder, divided by the 3x squared minus 2x. Sorry for those mistakes that were in there. I don't know what happened. But that is division of two polynomials. You might have to go back and rewatch that. The other example, I'm going to see if I can squeeze in here, is example 6 with objective 4. Use the factor theorem to solve polynomial equations. And if you haven't read the lesson yet, you don't know what the factor theorem is, maybe even if you have read the lesson. So we're going to talk about that. They give us a polynomial equation, 2x cubed minus 3x squared minus 11x plus 6. And they ask us to solve that given that 3 is a 0. So they told us a 0 already. If you tried to factor this on your own, factor by grouping would be really our only option, and even that one's not a good option for us for this problem. It doesn't work out. So our primary goal is to solve the equation. And we, I mentioned the GCF, the FOIL, the factor by grouping, sum and difference of cubes. That's how we normally solve equations. Unfortunately, those aren't good options for us right now. So we're going to use what was given, that 3 is a 0 of f of x. Okay? All right. Now, remember that if 3 is a 0, then we know the factor that produced 3. Okay, so this is kind of, we're going backwards to get a factored form. If 3 is a 0, then we can say x equals 3, because a 0 is an x value. And remember, a factor, we get the x equals 3 from saying x plus or minus something equals 0. And if you move the 3, it's going to be x minus 3 equals 0. So if 3 is a 0, then x minus 3 is actually a factor of our polynomial that we're trying to solve. Okay? All right. So the objective is to use the factor theorem to solve polynomials. And if x minus 3 is a factor, then we know that we can take x minus 3 times some missing factor. We call that the depressed polynomial. I'll show you that in a minute. will equal 2x cubed minus 3x squared minus 11x plus 6. And we can find this missing factor by separating the x minus 3 from it. If it's multiplied on the right, we're going to have to divide it over to the left. Okay, so we're going to divide both sides by x minus 3. On the right, they just cancel out. On the left, we're going to have to divide those. Okay, so again, if you divide these, you are going to find that depressed polynomial, which is this unknown factor for us right now. You could go back and do long division. If long division, you're good at that, you're efficient, you are accurate, you can do long division. But I want to remind you about synthetic division as well. It's up to you. The last problem, synthetic division, was not an option. Synthetic division requires that what you divide by be 1, a binomial, 2, it must be 1x to the first power, okay? We can fix it if it's not 1x, but we can't fix it if it's not to the first power, which was the issue in the last one. Okay, so in synthetic division, remember that the 0 actually goes inside this little box. And then we write the coefficients of our numerator in this top line. You would need to put any zeros if any were missing. We leave the next line blank until we go through it. So maybe I'll still do that. Okay, so the first thing we do is we drop the 2 down below. And then we go through this process of we multiply the 3, the 0, by the 2 down here, and we record the 6 we get underneath the next line. Okay, we then combine these two just as they're telling us to do. We take a -3, we put with it a +6, and we get a +3. And then we take the 0 again, the 3, multiply it by this 3 down here, and we get a 9 that we record in the next blank under the -11. And -11 and +9 produce -2. And then 3 and -2 give us -6. And 6 and -6 give us 0. Remember that last number is the remainder. So this tells us that when we divided by 3, by x minus 3 really, we had no remainder. That's what the factor theorem is. It says if you divide a polynomial by one of its factors, you should get a remainder of 0. You will. Okay, that's the factor theorem. And so that depressed polynomial comes from these coefficients, which are the polynomial 2x squared plus 3x minus 2. Remember, it steps down the degree by 1. You took a cubic and you divided by a linear, and that produces a quadratic. Okay, so there is our missing factor. All right, so to solve this and to get our answer, to find the solutions, we already knew that we had a factor of x minus 3. And now we know that the other factor is 2x squared plus 3x minus 2. So we can try to factor that quadratic a little further. And we factor it into 2x minus 1 times x plus 2. Now that we have all linear factors with multiplicity of 1, to remind you of our previous lesson, we can set each factor equal to 0 and find that we have 3 factors, x equals 3, x equals 1/2, and x equals -2. And here's the graph. X equals 3, here's 1/2, here's -2. Okay, so to recap, when we're given a 0, that is a factor. Okay, we change it into its factor. We divide by that factor to find the depressed polynomial, and then we write the given equation in factored form, and we solve from there.